Assalamualaikum. In this video, we would like to present to you our chosen topic, which is Logical Connective for Mathematical Logic and Proving Technique subject. Before we start, let me introduce our group members. My name is Nurulika Auni binti Jamisari, and my other group members, we have Nasiha Sofia binti Muhammad Nur Hisam and Nur Amira binti Abdul Aziz. So let's move on to the introduction. So what is logical connective? Logical connective are tools we use in logic to connect two or more statements. For example, we can combine two simple formulas like P and Q using this connective. They are also called logical operators, and there are a few types, which is negation, which means not, conjunction, which means and, disjunction, which means or, implication, which is if then, and biconditional, which means if and only if. And then we have tautologies, contingency, and contradiction. So this connective helps us create more complex statements from simpler ones, making it easier to analyze or express logical ideas. Logical connective are tools in logic to connect statements. This table shows the main connective, their symbols, and their meaning. So the first connective is conjunction, represented by the symbol, which means and. For example, if we say P and Q, it means both P and Q must be true. Next is disjunction, represented with that symbol, which means or. This indicates that at least one of the statement P or Q is true. The third one is negation, symbolized by that symbol, which means not. It negates the statement. So for instance, not P means P is false. And then we have conditional or implication, symbolized by that symbol, which means if then. For example, if P then Q implies that when P is true, Q must be also true. And the last one, we have biconditional, represented by that symbol, meaning that if and only if. For example, P if and only if means P is true if and only if Q is true. Next, this slide explains the conditional statement or implication statement in detail. So it's written with that symbol, which is read as P implies Q. Alternatively, we can express this in different ways. For example, we can say P is a sufficient condition for Q, or P is sufficient for Q. This means the same thing. We can also phrase it as Q is a necessary condition for P, or simply Q is necessary for P. Again, these expressions are equivalent. Another way to write it is P only if Q, which still conveys the same meaning. The key takeaway is that all these forms represent the same logical idea. In summary, conditional statements are versatile and can be expressed in multiple ways depending on the context.
Hello, my name is Nasiha Sofia. So let's talk about conjunction. In logic, a conjunction is a type of compound statement. This means it's a statement made by combining two or more smaller statements. A conjunction is only true if both individual statements are true. And the symbol we use to represent the conjunction is in the slide with the red color, which means and. Let's move at an example to understand this better. So the letter P, which is it is raining, and Q, it is cold. When we combine these two statements with a conjunction, we get it is raining and it is cold. For this entire statement to be true, both individual parts must also be true. If it is raining but it is not cold, or if it is cold but not raining, then the conjunction as a whole is false. This is why we say a conjunction is true only when all its parts are true. It's like a condition. Everything must happen for the result to be valid. So next, we will look at disjunction. A disjunction is another type of compound statement, but it works differently from a conjunction. A disjunction is true if at least one of the individual statement is true. The symbol for disjunction is also in the slide, which with a red color, which means or. Let's explore an example. For letter P, I will go for a walk, and Q, I will read a book. When we combine these two statements with a disjunction, we get I will go for a walk or I will read a book. If either statement 1 or statement 2 is true, then the entire disjunction is true. For example, if you end up going for a walk but don't read a book, the disjunction is still true. Similarly, if you read a book but don't go for a walk, the disjunction is also true. So the only time a disjunction is false is when both statements are false. So if you neither go for a walk nor read a book, then this disjunction will be false. So we move on to the next logical connective. Let's talk about negation. Negation is a different from conjunction and disjunction because it deals with flipping or reversing the truth value of a single statement. If a statement is true, its negation will be false, and if a statement is false, its negation will be true. The symbol for negation are on the slide and both mean not. So let's look at an example. For P, the sky is blue, and the negation is the sky is not blue. Negation is powerful because it allows us to express the opposite of what's being stated. For instance, if you're given a statement like it is raining, so the negation would be it is not raining. Similarly, if a statement says I am happy, its negation would be I am not happy. Let's talk about conditional statements in logic. A conditional statement is used to express a relationship between two statements. It's written in the form if then, where the first part is the condition and the second part is the result or consequence. So, conditional statements are interesting because they are not always true or false in the way you might think. The key to understanding them is a conditional statement is false only when the first part or condition is true, but the second part or result is false. In other situation, the statement is considered true. So let's take an example. For P, if it rains, and Q, it will bring an umbrella. So when we combine this statement into a conditional, we get if it rains, then I will bring an umbrella. In this example, the first part, if it rains, is the condition. The second part, I will bring an umbrella, is the result or what will happen if the condition is true. The entire condition will only fail if it rains but I don't bring an umbrella. And lastly, the logical connective is a biconditional statement expresses a logical relationship where both statements must have the same truth value for the entire statement to be true. This means the biconditional is true if both statements are true or false. If one is true and the other is false, the biconditional is false. Okay, so for the symbol for biconditional is also in the slide and it is often read as if and only if. So for P, I will eat cake, and Q, it is my birthday. If we include the biconditional statement, it will be I will eat cake if and only if it is my birthday. This means that eating cake will happen only on your birthday. And if it's your birthday, you will definitely eat cake. The two events depend on each other perfectly. That's all for me. Thank you.
Next, I would like to share with you guys about some question. Let's look at the first question. For the first question, we need to write the following proposition in symbols where P, Sarah's car key is in her purse. Q, the key is on the kitchen table. R, she can start her car. And S, she needs to call her husband. Question A. If Sarah's car key is not in her purse, then the key is on the kitchen table. So the answer is the negation of P implies Q. Question B. If Sarah's car key is in her purse, then she can start her car. So the answer is P implies R. For the question C, the question is if the key is on the kitchen table, then she needs to call her husband. So the answer is Q implies S. For the question D, Sarah can start her car or she needs to call her husband. So the answer is R or S. Next, let's look at the question 2. For the second question, we need to write the following symbols in a sentence where P. Today is raining. Q. Alia will go to school by bus. R. Alia had breakfast at home. S. Alia will play the piano. And T. She will walk to school. Let's look at the question. Question A is P and Q. So the answer is today is raining and Alia will go to school by bus. For the question B, P implies bracket R and Q. So the answer is if today is raining, then Alia had breakfast at home and Alia will go to school by bus. Next, question C is R implies bracket S or T. So the answer is if Alia had breakfast at home, then Alia will play the piano or she will walk to school. For the question D, it is the negation of S. The answer is Alia is not playing the piano. For the question 3, we need to write the following proposition in symbols where P. Amin is practicing singing. Q. He is playing a guitar. R. Salwa will play the violin. S. Amin will perform at a show at PWTC. And T. Salwa will give him a guitar. Question A. If Amin is practicing singing, then he is playing a guitar. So the answer is P implies Q. Question B. If he plays a guitar, then Salwa will play the violin. The answer is Q implies R. Next, question C. Amin will perform at a show at PWTC or Salwa will not play violin. The answer is S or the negation of R. Question D. Amin does not perform at a show at PWTC or Salwa will give him a guitar. The answer is the negation of S or T.
In conclusion, logical connectives are fundamental in propositional logic. They help in forming compound statements and determine the truth value of the statement based on the truth value of their components. So here's a quick summary of the common logical connective and their symbols. First, conjunction, which means and. The compound statement is true only if both individual statements are true. Second, disjunction, which means or. The compound statement is true if at least one of the individual statements is true. Third, negation, which means not. The negation of a statement is true if the statement is false. And then we have conditional, which means if then, and biconditional if, which means if and only if. So in propositional logic, we use symbols to stand for the relationship between statements. Connectives are used in compound statements, each of which composed of at least two statements. And the last one, a statement is a sentence that can be either true or false.